Good afternoon, one and all present here. Now, in the second session of today's event, Dr. Melvin Joe Thomas will be handling the session. Melvin Joe Thomas serves as Assistant Professor in the Department of Mechanical Engineering at NIT Surat. He is also an Associate Faculty at the Center for System Design, NIT, and currently serves as an Institute Outreach Coordinator for Virtual Labs project at NIT. Dr. Melvin earned his PhD in Mechanical Engineering from National Institute of Technology, Calicut, where his research focused on robotics, mechanism synthesis, optimization, and control. He also holds the MTech in the machine design from the same institute. Following his doctoral, he pursued postdoctoral research at IIT Palakkad, contributing to diverse domains with robotics, including medical robots, mobile robots, and soft robots. Driven by the passion of innovation, Dr. Thomas actively collaborated with student and research to develop advanced robotic system that addresses real-world challenges. His expertise spans mechanism, design, control system, and intelligent automation, with notable contribution to the development of unmanned aerial vehicles, smart medical devices, and soft robotic technology. His research outcomes have been published in several peer-reviewed Scoopus Index journals, reflecting his sustained commitment to advancing the fortunes of robotics and mechanical engineering. I welcome Dr. Melvin Joe Thomas on the dais.
Thank you very much. So one major challenge that I'll be facing is the timeline that was given to me. One is that it is very soon after the lunch. So there are very high chances that many of you might doze off, because I could see a few dozing off in the morning session also. So it's a bit more challenging in the morning, right? So what I'll do is I'll probably speak using the mic so that the sound can prevent you from sleeping to some extent, right? So what I've decided, from the morning session I've been attending, so I could see that not many are from the background of hardware robotics. Mostly, most of the crowd are from CS IT backgrounds. So what I intend to do for today's session is I'll keep the mathematics and all the related jargons as limited as possible. So what we'll do is we'll try to discuss more of the concepts which is related to the hardware development. Because what I strongly feel is, like any robotic system which has a hardware, you just eliminate the controllers, you eliminate the sensors, you eliminate the actuators. What it leaves behind is basically a mechanism, or the skeleton is basically a mechanism. That is where the concepts of mechanical engineering comes in play. So we all know that robotics as such is a purely interdisciplinary field which needs all aspects of engineering to be included. Because now in the recent times also, if you observe, we need also some expertise of chemistry, especially while synthesizing newer materials in order to come with smarter materials for different applications. So it involves literally every field. And so what I'll begin with is, so as per the title of the FDP, which is Intelligent Automation Leveraging Robotics, AI and Internet of Things for Industry 4.0. So keeping that in mind, I am thinking of discussing some of the concepts which has more relevance in the present scenario. And that is what we call as the collaborative robotics. So probably Professor Guru Prasad has already given some glimpse of these concepts. And what I will be taking up is, again, as I told, I'm not going into the core mathematical modeling, because it is actually important when we develop a robotic system. But we'll discuss some fundamentals, that's it. So this collaborative robotics, even most of you must have come across the terminology called as cobots, COBOTS. It's actually a shorter version of collaborative robotics. and cobots are also becoming very popular. So to make it interesting for both of us, let's have the session slightly more interactive rather than just me speaking, so that all of us will be engaged with this kind of this event going on. Okay. So what we'll begin with is discussion of cobotics, and so before I go into that, I just thought of just giving you. Is it possible to switch off the slide if possible? Because the slides, maybe you can keep the audience slides. Yeah. Yeah, you can keep the audience slides. Just yeah, this will do. Probably those slides can be kept on. Yeah. So I reached today morning. So I happened to move around this campus, and I found that the campus is pretty good. So I just thought of even showing off my campus. So I just want to know how many of you have been to NITK before this? Yeah. So we have probably 2-3 people only in the campus. So I just wanted to show you our beautiful campus, the NIT Surathkal. So this, I'm just using this as a platform to also, if officially, I understand all our faculties here, probably all our faculties. So I'm also officially inviting you to campus in case if you wish to come to the campus, please put me an email so I can make arrangements for the visit to the campus. And also if you wish to send your students for internships, again, in the same approach, you can put me an email. So I'll make arrangements for internships. In case any of your students are interested in doing master's program in our campus, again, so these are different ways where you can explore our campus, because it's not something which you can finish in like maybe one day. We have nearly 300 acres, of which we also proudly say we have a beach alongside. It's only NIT. I suppose it's the only campus in India which has own beach. So we have all these facilities. So this is the quick drone image of our campus. And probably this building that you see here is the mechanical engineering. So we still also proudly say that NITK is one of the campus with, again, the largest intake. We have larger intake than the CS backgrounds, because normally there's a trend where the CS is more, or the IT intakes are more than mechanical. But still, we still have that practice of having the mechanical engineering students more. I'm not trying to boast our department, but just trying to let you know. And robotics, where I work on, is part of. Okay, now like we are not trying to just disclose it to just one department, because I probably work with literally all the departments. So we are trying to have a more central interdisciplinary related works, collaborations, transdisciplinary also, because NIT Surathkal is also blessed with a number of hospitals nearby. So we also have discussions with doctors, and that's how I moved into medical robotics. So they have many problems which we as engineers can give solutions, right? So we do all those kind of research in our institute. Okay, so yeah. Okay, these are just some statistics. It's all available. So we have all 9 departments, three centers as such for research. Then we have the science departments and the HSS, right? So this is just a quick glimpse of our institute. So as I told, if in case you wish to come to the campus, just let me know, put me an email. We can get connected. And also if you want to look for collaborative projects, that is also open to us. Okay, right. So now moving into the subject that we are going to talk. So collaborative robotics, which is also shortened as cobots. So like Professor Guru Prasad mentioned in the morning, it's always best to keep the robotic system as simple and as dumb as possible. Like in the sense, in terms of like, let it be the computation, let it be the complexities involved, let it be the cost. So due to several parameters. So keeping that in mind, we have come to this concept of collaborative robotics. Now, can anyone tell me what do we actually mean by these cobotic systems? Or have you come across this terminology called cobots? Very good. So it is a scenario where humans and robots. Okay, so there are different aspects. Dual arm coordination. Coordinated robot is a different concept. Swarm robotics is a different thing. What I am going to discuss here is cobotic systems, collaborative robotic systems, which is a kind of interaction between a robot and a human. And can you tell a reason why could be collaborative robotics or cobotics is getting popular in industries? Safety. Okay, fine. Human robot interaction safety, that is actually one requirement that we need. But what is the major reason why cobotics is getting popular? Losing jobs. Okay, these are some secondary fruits that we get. Backup jobs, fine.
Industry 5.0, they are losing much of them.
Fine. No, that's what we are seeing nowadays. There are a lot of, if you observe, many of the industries, many of the automation, or many of the big giants, if you observe, you see robots and humans working together. So coming back to the same question, why is that happening, or why is it getting popular? Like we, or as we probably discussed in the morning, autonomous robotic systems, which will completely do the whole task. Sounds good, sounds fancy, sounds like a better option. But still, if you see the big giants, they are not popularizing. They do that only for certain tasks where humans, where it is hazardous to humans or where it is not suitable for humans. But like for example, if you take the case of in automobile industries, the painting job is still done completely by either it's remotely operated or the robotic system is alone in a closed space. But in certain other, for example, in assembly units, you can see that robot and humans are working together. So it's not a very high, tough question which I'm asking. If you just logically think, there is one great advantage that we'll get with
High production cycle times.
high production cycle time. See, automating can also do to some extent. Complicated works can be easily done. Yeah, I'll take that. So what the major reason why cobotics are getting popular is because, see, if we need the robotic system to take the whole of the decision, it means more sensors, it means more advanced controllers, it means more advanced computation, which indirectly is going to add to the cost of our robotic system. On the other hand, if the decision making can be done by the human, and the task which is difficult for the human can be done by the robot, it helps us, right? Can you understand? Can you imagine what's the situation? Just imagine I don't know whether I have that image. Yeah, just imagine this is one task. Now, if you observe most of my images, these are not real images. These are all AI generated. Okay, all are AI generated images in the picture. So now if you observe this picture, you can see the task is to assemble the windshield of the vehicle correctly to the required location. Okay, and now you observe the person is also there. We also have a robotic manipulator. So we already discussed in the morning robotic manipulator. What is a robotic manipulator? It was beautifully described. So so you know what it is now. Now, if I want to do this autonomous, if I don't want a human to be positioned there, can you tell me what is the level of complexity in doing this task? Accuracy, the level of precision, because we need to make sure that the assembly correctly. Do I have that pointer? Is it there? There's no one? Okay, fine. Okay, so you can see that we need this windshield to be correctly positioned here. And if in case I want this robot to work alone, if I need to make it happen alone, all the concepts of trajectory planning, path planning, the sensor feedbacks, everything is going to come in play. On the other hand, what is the difficult part here for the human? The difficult part for the human here is to correctly balance that windshield, the weight of that windshield. Let it be anything. This is just one example. The same is going to happen for the panoramic sunroof in vehicles. It's a long glass, or whatever be the situation. You can see that whole weight is as such taken care by the robotic system. But the motion, the movements of the robot is actually manipulated or is actually controlled by the human. So now what is the advantage I'm going to get here now? As I already told, it will help me in making more simpler robotic systems. It helps me in deploying a comparatively lower cost robotic systems in industries in place of a very highly advanced, highly sophisticated robotic systems. So even medium and small scale manufacturing industries also have the option of doing this automation. And then we also have the secondary benefits as like many of the colleagues mentioned here, that the job and all those, but that is not the primary reason. So this is one major reason why cobotics is getting popular in the present scenario. Okay. So that is like what I've mentioned. So why cobots? So it's like demand for mass customization. So this is one another major advantage. Now just imagine after 1 year, probably if you see the cases of the modern vehicles or mobile phones or let's not take mobile phones, let's take the case of automobiles itself. You can see that nearly in every 8 to 9 months, new models come into market. So if a new model comes into market, of course, the design, the vehicle, the position of each parts will accordingly change. And if I am having an autonomous robot, what does it mean? I have to completely reprogram the whole system. Reprogramming is again an additional cost. On the other hand, if it is this cobotic systems, the customization is very easy, because it's just you need to train the personals, the humans, who is actually going to position the required components. This makes it very advantage. The one big advantage that we get with the use of cobotic systems. So secondly, as consumer demands shift towards more customized products, manufacturers need flexible automation. It's more or less a similar meaning. Then cobots can easily be reprogrammed to handle frequent product changes. So all these three statements are literally the similar meanings. So this is the major advantage that we have if we use or deploy a cobotic systems inside the robotic system. Then what is the second advantage? Flexibility for small and medium enterprises. So as I already mentioned, the robotic systems gets a bit more affordable compared to a fully autonomous robotic system. Then easy to program and deploy for different tasks. So again, the robotic system, in case if I want to completely reposition the sequence of operations, if I want to use one robot for some other purpose, it is possible, because the robot as such does not have heavy levels of intelligence. It will be having certain sensors, maybe some limit switches or some limits, which will give us a feedback to the user. But most of the decision making as such is not happening with the help of the robot intelligence. It's with the help of the human intelligence itself. And then improved technology works safely side by side with humans without safety cages, unlike traditional industrial robots. If you observe, now if you see, it is not very much there, but in the earlier industries, if you observe, which was completely automated, you could see that the industrial robots were completely, it was like a wild animal. It was inside a caged system. But now if you observe, that kind of a situation is actually being changed. And now it is like humans and robots work together. And this is where the concepts of even soft robotics have come into play. I presume you understand what I mean by soft robotics. Maybe we'll discuss a bit more on that as well. So soft robotics means we are actually now, like if you again just recollect what Professor Guru Prasad mentioned, he was talking several times rigid. The term rigid was being used, even if it is not actually in real life present, but we assume things to be rigid. Even it makes us easy for us to do the mathematical modeling. Because modeling a system which is flexible and modeling a system which is rigid, the maths involved is highly different. It is entirely different. So for this reason, so soft robotics, of course, the modeling is highly nonlinear. It is very flexible. So we'll have to use some other concepts, but there are several other advantages. The advantages are, one is the safety. It makes it useful for makes it more user friendly, makes it more safe environment for the humans to operate. The chances of accidents can be limited. So these are few of the many advantages that we can get with in deploying the soft robotics. So I believe this might be known to many of you, especially from the CS and IT. So can someone tell me what we mean by the Moore's law? How many of you know what is Moore's law? I've heard. We have only one person. So what does this Moore's law say?
Rate of rise of technology.
Correct. It is something to, I just brought this into picture just to give you a flavor, taste of, the level of developments happening in technology. So this Moore's law, which was framed back in 1960s, so it's a pretty old law which he has given. So the Gordon E. Moore, that's a person's name. So that's how this name of this law also came. It was what he mentioned was back in 1965. What he mentioned was, this is probably you must have seen this picture somewhere, possible. It's a very well-known image. So what he mentioned was, Moore's law is the observation that the number of transistors on a microchip doubles approximately every 2 years, while the cost of computers is halved. So this was his observation. So now if you see, this was back in 1960, but now I would like to modify this, that it is not, as per his statement, it is a linear development. So now what does, if you decode the statement, what does it imply? Number of transistors on a microchip doubles. When the transistors, it simply refers to the ability, the computational load that the system can handle is improving. And as that is improving, what is happening? There is a reduction in the cost. The cost of the computers is halved. So it's kind of a linear equation if you observe. But I would say now in the present scenario, the things are happening in a very exponential growth. It is not a linear growth. You'll have developments in technology. You'll have developments in many elements. Even recently, I happened to attend one summit, and we actually feel things that we see in some science fiction movies are actually going to come in real life. It's happening. Maybe back in 1960s, when people were dreaming of things which are happening now, the same is going to happen. Maybe in another 20 years, the level of technology will be entirely different, and the cost, because maybe in the initial stages the cost may be high, but in due time it reduces, and it is very evident. Like, let us see, like any electronic or gadgets, anything that you observe, it's a similar trend. So as you move forward in time, there is a very huge improvement in the level of AI, or in the level of the feedback that we get in the systems. Even recently, I happened to talk to the R&D head of Amazon in Bangalore. So what he was saying is, they have a statistics which says that, but their statistics was based on US, not in Indian market. But what they were saying was, in 5 years' time, they are predicting that every household will have at least one robotic system in their household. That is what their statistics says. So that means in US, there will be, it may be in any form. It could be either in form of a companion robot. It could be in the form of a vacuum cleaning robot. It could be in any form. But there will be every household with at least one robotic system. So that is the level where they are looking, and that is what they are doing research, right? Even if you observe, like, see, I just bring one another context. If you take the case of 3D printing, if you see the literatures, the concept of 3D printing has been there around for the last 40 years. It has been there around. This technology of 3D printing or additive manufacturing, different terms you can call it, has been there for the last 40 years. But if you observe in the last 5 years or last 10 years, it's literally there in some households also. That is, you can see. So that's how the technological developments are happening, right? Okay. So more transistors, yeah. So this is just like I just wanted to mention. So more transistors, more computing power. So why does it matter? Driving down the cost of electronics, making devices more powerful and affordable, enabling technologies like AI, cloud computing, and advanced robotics. So I just wanted to show you a flavor of what we are going to witness maybe in the next 15 or 20 years. And again, if you observe in our Indian scenario also, there are a lot of fundings, there are a lot of, you know, scope where, you know, we can actually, you know, have huge developments in even in the institute level as well as in industry level. Okay, so the number of robots. So this is just one statistic which was released by the International Federation of Robotics. Again, as I told, for purpose reasons, I'm just showing some statistics so that it doesn't bore many of you guys, right? Just again, it's a very evident trend. We can observe that there is a huge increase in the number of robotic systems in the sector of service. Okay, now let's just talk about service robotics. Now, if you observe robotic systems as a whole, robotics is not limited to just one sector or one domain. It's literally there in every domain. You take household, it is there. You take industry, it is there. You take hospitals, it is there. You take hospitality, it is there. You take military, it is there. So you name any sector. So that is where the scope of robotics is also lies. So it has application literally every field, space, of course. So that's you know the kind of scope that we have for the field of robotic systems, and that's one reason why there will be a lot of research and developments happening in this particular field. Okay, so this is again another statistics by the IFR, the International Federation of Robotics, which is showing the units of robotic systems which are sold in different sectors. So transportation and logistics, hospitality, agriculture, professional cleaning, medical, and so on. Okay. So now let's just try to understand where are we right now in the present scenario. In the present scenario, where are we? So it begins with, I probably must have seen some news articles on these kind of things, right? And a lot of research happening in the field of, what do we call these kind of robotic systems? Humanoids. Yeah, the humanoid robotic systems. So what is basically a humanoid? So again, like professor in the morning has already explained what is a robot and all those aspects. He has given an clear definition. So now again, depending on the construction, depending on the configuration, there are different forms of robotic systems, of which one of them we have is the humanoid robotic systems. So that means it has a body ratio similar to that of a human being. So any robotic, it need not be a full adult size 1:1 scale robotic system. There are miniature versions also. You must have come across the Navo robot. The Navo robot is it's a 3 feet tall robotic system, but it has the body ratios of a human being. So recently you must have seen that it has a lot of, the most recent we have the Tesla robot, which is called as the Optimus. So this is again one statistics. Again, I have lined it together making use of AI tools. So you can get a glimpse of the top level, humanoids that are available. And there are still a lot of researches happening, because you will observe maybe in the very near future, we will have such humanoids being deployed to do certain very basic unskilled jobs. And right now it is expensive. As I told, using the concept of Moore's law, we will see that it becomes affordable in the coming future. So that is how the future is going to be. Probably that robot which you see there is known to you, right? Sorry. So this robot that you see here, this one, this is called as the Sophia robot. So the Sophia robot, which is developed by the Hanson Robotics, based in US. It has many, it's basic just GK. It has many special characteristics. It has citizenship. Do you know which country has given the citizenship?
Dubai.
It is not UAE. Dubai is part of UAE actually. It's Saudi Arabia. Saudi Arabia has given citizenship to this robot. And uh, the CEO of this, it's developed by the Hansen Robotics, and the CEO is Hansen's wife's face is what is given to this robot also. Okay, it has many such features. It also has real-time um, answering and facial expressions. It has many such features, and it has also come to India. Probably before COVID, it had come to it has traveled to literally many parts of the world. It interacts with people in real time. It had come to IIT Bombay, where it interacted with students and so on. Similarly, the video that you see below, this is also a very famous viral video which was released by do you know which company? Boston Dynamics, which is also one of the pioneers in the field of humanoids. They also do develop the robo dogs, quadruped robot, the four-legged robotic system. So these are different names actually. So if it is a two-legged robot, the two-leg systems, we call it as a biped. So I'm just, because since you guys are from, mostly all of you are from the CS and IT background, I just want you to get some flavor of, the mechanical or the hardware construction of robotic system, which is also equally important, because it's not just the AI part which is important or the algorithm part. We also need to have a well-structured hardware in order to have the robotic system to operate as per our requirements. So if it's a two-legged, we call it as a biped, so quadruped. So these people are they have been working for more than 2 decades in this field of legged robotic systems. And now if you see this video, it does a lot of tasks. If you observe, it can climb obstacles, it does dancing, it does many things. But let me frankly say, it is not very easy to develop such a thing. It is a very highly complex system. But again, as I tell, we can see or observe many of such things happening in the coming future. So these are again some of the applications which I already mentioned. So this, have you observed in news articles anywhere this particular thing? So this is actually, if you happen to go to the police headquarters of Kerala in Thiruvananthapuram, you will observe this humanoid robot being deployed. It is also given a SI rank. They have given SI rank to this robot, and it plays the role of a friend desk. It gives the people information. So they have deployed a robotic system there. Similarly, second is it's again a screenshot taken from a movie, which is again a South Indian based movie. And I just want to bring some interesting facts about this. So these kind of robotic systems, what you observe in the middle, again, it works alongside with humans, and such robotic systems are called as the companion robots. Call it as the companion robots. And if you observe, again, literatures and patents and developments, if you observe, most of the companion robotic systems that you see are actually developed by the Japanese people. Now, do you know what is the interesting fact? Why is it so? Why is nearly, if you see the literatures, nearly more than 90% of the literatures and developments and patents on such companion robots comes from Japan. The reason is because as per their statistics, they say that by 2075, they say that 75% of their population will be having an age of above 75. That is what the statistics says. And so by the time they reach this age of 75, they want a fully developed human. This is one of the interesting article which I came across. And they do a lot of research in this aspect. And they also have this kind of observation that many people there in, like especially in the elderly side, they live alone. So they need someone to talk with, to do some, take care of, give some reminders, give some information, make some communications at home. So for this purpose, they do a lot of research in developing such kind of companion robotic systems. And again, there's a huge development happening in this field. Then we have, again, there are a couple of restaurants actually in India as well as in abroad where they have started using robotic systems in hospitality, in restaurants, for serving food and so on, for greeting people. So that is the application of robotic systems in the field of hospitality, right? And then finally, this one is again, it's another application of the uh, companion robots where they use it in hospitals, as you can see. And it also became more popular during the era of COVID, which was nearly 5 years back. So it also does some basic tests it can do, and also it can interact with doctors who are maybe in quarantine in some other rooms in real time. Okay, based on this, there are certain concepts also. That is this concept of telepresence. So it is like similar to a human who is taking the avatar of a robot and moving across the hospital. So he may be in some other country, while this hospital will be in some other country, but maybe he will have to take rounds. So what he does is he makes use of this concept of telepresence. We call it as the telepresence, where the robotic system. So again, I just want you to observe some things. Now, if you see, each robot which I'm showing has different forms, different structures, different designs, different configurations, the choice of the. So if you specifically say the types of robotic systems, we can actually categorize these robotic systems into n number of ways or n number of types, depending on the construction, depending upon the intelligence levels, depending upon the payload it can take, and so on. Right? So this is one concept on the telepresence, where it can move around, and also it can also interact with people in real time. And also, as I told, it can also do some basic tests in order to get some quick feedbacks to some extent. Then the concept of swarm robotics, I believe you know what it is. So what is swarm robotics?
Multiple robots are communicating with each other.
Correct. So that means when we have robotic systems, when we have multiple robotic systems which are deployed inside a restricted environment, such field, that means it involves again all these concepts where the path planning and the motion planning, the concepts of SLAM, of course, all these things comes in play there, right? Localization, mapping, interaction, coordination, and so on. So this is again another video which I've taken from YouTube actually. So where they have deployed one of their godowns in US of Amazon facility. So when an order is placed, it goes to that. And they have also designed it so there may be different logistics reasons why they have designed their robot in such a way. So what if you observe in this design of their robot, you can see that they have not designed a robot with an arm or a manipulator which can go and pick. Maybe they thought that it is going to make it more complex or make complicated. So what they have done is they have designed the robot in such a way that it carries the whole shelf itself. The info regarding that product will be there given, and it will carry that whole shelf, and it will go to a person who will be standing. There's only one person who is going to run this whole go down. So once the order is placed, it will go there, and the person is the one who chooses the required component from the shelf, and then it's taken back to the required space. This is the kind of algorithm they have used in one of their facility. Again, they do a lot of research happening in this field. Now, so now talking about constructing a robotic system. So as I told, now what we have discussed is I have just showed you a very quick glimpse of the various forms of robotic systems that are available. So I thought like I'll spend some time discussing what are the various forms of robotic systems that we can have. So you can see the construction of each of the system is different. It highly depends on where it is being deployed, which application it is being used for. And that is very important because again, in case when you are working in some specific, in developing a certain robotic system, it's very important that you choose each component of the robotic system wisely or in a very optimized manner. Now, if you observe, the first one is a very well-known thing. It is kind of very commercial. Nowadays, you will find this vacuum cleaning robotic systems in literally households. Literally, it is now becoming very popular. Now, this is the robot dog, which I mentioned, which is a 4-legged robotic system. Then you can see, now you can observe in this again. So this is actually a very independent field, which is mobile robotics, because talking on mobile robotics itself is an independent course. Now, if you see in this the middle thing, there are different forms of wheels. Now, if you just imagine that you have decided that I want a robotic system which is going to move in different places. Now, accordingly, there are different types of wheels which you can use for manipulation. The most basic is, okay, let me just ask, does anyone know what is the most basic form of a wheel that we can use for a robotic system? Has anyone worked on hardware development of robotics systems? No one. The Omni wheels. Okay. So the Omni wheels, which is also called as the mecanum wheels. Do you know what is it? That is exactly what you see in the middle. The most basic form of a wheel is what we call as a differential wheel. That means you'll have a regular 4-wheel or 3-wheel, whatever it is, which can only rotate as per our convention. So if I want to take a turn, so if you observe a regular 4-wheeled vehicle or a 4-wheel car, it's basically an example of a differential wheel robotic system. And now in case of automobiles, the front wheel can be used, we can turn. But in robotic systems, we don't have a steering to turn. So in differential wheels, what do we do? Yeah. So that means if, now just imagine like this is my robotic system. So what we do is, this is one differential wheel, this is one another differential wheel. Normally what we do is we give some caster wheel in the front normally. What is a caster wheel? For example, if you must have seen these office chairs, right? The wheels which are given below, those kind of wheels are called as a caster wheels. Those are not manipulated or controlled by an actuator. We don't have a motor connected to those. Depending on the direction of motion, it accordingly moves. Now, if you observe in this case, these two wheels, if I'm using a conventional wheel, if I want to move in straight line, what should I do? If I want a robot to move in straight line, what should I do? No, I want to move it in straight line. So that means both the wheels will be given the same RPM in the same direction. Is it? You're getting right? It's moving in the same direction. So I'll move straight. Now, on the other hand, if I want to take a turn, what should I do? I want this robotic system to take a turn. Okay. Correct. So that means that is why we call this as a differential wheel. Now, do you know why this term is given differential wheel? Okay, let me just ask you some other question which is slightly outside robotics. Have you observed that we use a differential in vehicles, in our regular cars? What is the purpose of this differential? Speed synchronization between wheels while taking a turn. So now what is that? What does it imply? So that means, for example, if I have a it's more dominant. If in case like you observe a truck, a huge truck, you can see in the backside some ellipsoid shape like thing, right? In the backside. It's basically a differential. We call it as a differential. And the purpose of this differential is that, for example, if I have, this is my vehicle, and if I'm taking a turn, when I'm taking a turn, what happens? You can observe that if this is my path, you can see that the inner track is having lesser distance to be covered compared to the outer track. Or in other words, the RPM that I need for the inner side is different from what is required along the outer side. So this synchronization, as he said, is made to happen with this use of differentials. It's basically a planetary gear system, but that is pure mechanical engineering. Let's keep that aside. So based on that, same in that, using that concept here, now if in a robotic system I want to take a turn, what should I do? For example, if I'm keeping my left side wheel static and I'm only rotating my right side, what happens? It will take a round turn, U-turn. On the other hand, if I take this one smaller, lesser RPM and this one more RPM, what happens? It takes a turn. So this is the concept of differential wheels. Then we have, as I said, the mechanism wheels, which is also called as the omni wheels. So which is a very interesting construction. So you can see when it is made to rotate as per our usual form, it moves like a differential wheel. And it has, if you observe the construction of the mechanism wheels, it has rollers on the outer circumference. On the outer periphery of the wheel, it has some rollers. Now, what is the need for this? Now, if you actuate, now the interesting part of these kind of wheels is that if we actuate the diagonal wheels in opposite directions, that means if the two diagonals are actuated, that means we have the two diagonals, both two diagonals are actuated in opposite directions, we find the interesting phenomenon that it can move. That means the robot which can move like this will begin to move sidewise. So we need not, unlike in differential wheel robots, I need not take a turn like this. You can see that in this case I need to take this much of trajectory motion. But if I'm using these wheels, I can use direct sidewise motions. So again, the reason why I'm discussing this is because depending on what is the application that I'm going to use my robotic system, accordingly, depending on the application, the type of wheels that I'm going to use will also change. Now, on the other hand, if I'm going to use it for a slightly more rugged application, outdoor or military related, we have these kind of track wheels. You can observe the tracked wheel robotic systems. So this is more used for outdoor kind of environments, or it can also it can also overcome some kind of obstacles to some extent, right? How many of you have seen this movie? Has anyone seen this movie? Okay, we have very few people, right? So this movie, I'll just, like, for those who have not seen this, so it comes in the it's called as the Iron Man. So that's the name of this particular movie. Now in this movie, I'm not going into the very much details. I'm just talking only specific to the. So this person, so the character's name is Tony Stark, and he is a very rich, and also he's a innovator. He's a designer. He's into many things. So he develops these kind of suits. So what these suits does to him is, it gives him additional power to do. So that means when he wears the suit, he can fly, he can shoot, he can do a lot more of things than a regular human being. So what does it mean? So when this person is going to wear this particular suit, he is going to get some additional power to do more things. So in the absence of this suit, he is a regular human. Now in perspective of robotics, can you tell me what do we call these kind of things? So this is how it looks. You can see this is the suit, this is the different parts. So it has a head, it has a body, and all these things. Okay. So now let me just bring it. So this is the movie which we discussed. As I told, just understand this much. So when he wears it, he gets some additional power. Now in robotics, can you tell me what we call these kind of things? We call it as the exoskeletons. Have you come across this terminology? Exoskeletons. So what does it mean? It is a wearable robotic system. It is a system which is wearable. So now let us see in what direction are we right now. So these are some of the applications. So you can see when the person wears this exoskeleton, or we also call it as, in some cases we call it as exosuit also. So when the person is wearing this, it gives him some additional support, or it gives him some additional power. Now if you observe the first picture, so now this picture, now if you observe this picture, sorry. So if you observe this picture, what happens? It's not working.
This works fine, I guess.
Yeah. So when this person wears this, now you can see this is a lower limb exoskeleton. So there are exoskeletons again can be classified into upper body, lower body. So the purpose of this exoskeleton is, can someone tell what is it from this picture? So it's like this person is trying to lift some payload. So its application comes in the field of logistics. Now just imagine the person is trying to lift heavy payloads. So in the Indian scenario, people are least bothered, maybe because labors are available in splendid and they are not bothered about their health. But in long run, what happens? It's going to affect that person's health, because he's going to lift that 10 kgs or 15 kgs load on a daily basis. It will create chronic back pain or some other issues. So we have these kind of robotic systems. Unfortunately, I was in collaboration with we call it as the CAIR, CAIR, Center for Artificial Intelligence and Robotics, which is part of a subsidiary of DRDO in Bangalore. So I was involved in a project with these people in developing a lower limb exoskeleton for logistics applications. So what it does is, if the person is trying to lift a 10 kgs load, the person will get a feel, or the effort that the person needs to put is only for 1 kg. The remaining 9 kgs of load will be supported by the actuators that are provided at the hip, the knee and the ankle. Now what is the important part here? Now if you observe, the weight of this exoskeleton is actually coming onto the human being. So it is very important that it is to be designed as lightweight as possible in order to reduce the fatigue on the person. So again, there are a lot of researches happening. Now if you observe this picture, again I've taken online, is an application of rigid mechanisms. As I told, now there are a lot of research which is happening in developing such exosuits, which is like something like a fabric-like suit, which you can wear like a sock, and it will give you the support. So when I'm trying to lift the load, the effort that a person is going to take is less compared to without the device. Now the next application you see is, it's a simulation which was done where the person is paralyzed lower body. So you know that. So for example, if I want to do certain task, I need to have the muscle power to do that operation, right? Or else due to some reason, either some nerve related issues or some neurological issues or some other problems, he may not be having that connection. But we can give, that means instead of using his or her muscle to do that operation, we make use of these external actuators, which are basically motors, in order to execute the motion. So that is what. Similarly, this is what you see below is the application for upper body. So that means he's using his EEG signals. So again, there are a lot of researches happening in that field also, because extraction of EEG signals is also a very complex task. There are a lot of research studies happening in this particular field. Even extracting EMG signals is also a very huge complex task, but still a lot of research happens. So if the person is thinking of lifting a mug from the table, that EEG signals should be extracted, and that should be given as an input trigger in order to make the motions happen, right? So I just wanted to show you that this is another form of an exoskeleton. So if you observe, this is another form of an exoskeleton. Oh, sorry, another form of a robotic system, which we call as an exoskeleton, which is coming in the category of wearable devices, wearable robotic systems. Okay. Again, this let's not talk much. It's all understood. So you can see the different forms. So the first one is again another example of a robotic manipulator, which is being used for spot welding operations. This is in military operations for diffusing bombs or related such applications. Okay, this is also another form of a robotic manipulator. Now, in general, whenever we say a robotic manipulator, what is that comes into your mind? It will be in general a robotic arm, right? That is what normally comes into your mind, which is actually coming in the category of serial manipulators. Okay, I'm not going to bore you with many of the technical terminologies, but maybe in next time when you happen to read any journals or articles related to robotic systems, you might able to relate. So robotic manipulator in general, what we say is a serial manipulator. Now, what is a serial manipulator? A serial manipulator is something that means the construction of robot is in such a way that each link is connected one after the other in a serial configuration. Now, if you observe in this case, in that robotic manipulator or this manipulator, you can see this is one link, second link, third link, and so on. And if you observe, the end effector is at the free end. So it is more like a open chain mechanism. So serial manipulators are also called as open chain mechanisms. And there is one another category of robotic manipulators, which we call as the closed chain mechanisms. So what is a closed chain mechanism? So what is the difference? So the other one is each link is connected one after the other in a serial configuration. It's an open tree mechanism, and the end effector will be at the free end. The closed loop mechanism, on the other hand, is, if you observe, now you just imagine this. If you observe this, I'm going to connect here with one another revolute joint. Now, if you observe, this mechanism has now got transformed into it's a closed loop mechanism. Or in other words, the end effector will be connected by multiple legs. Now, if you observe in this picture, so again they have used, if you observe in this picture, they have used the end effector is something which is used for pick and place. And you can see that the end effector is actually connected by multiple legs. Can you imagine that? Are you able to picturize? So such mechanisms where the end effector is actually connected by multiple legs or multiple links, such mechanisms we call it as parallel mechanisms. So now we have seen two. One is serial mechanisms where it is an open tree mechanism. So I'm just giving you this glimpse to get an idea of, if in case you have some application, you need to choose what should be the required design. So one is an open loop mechanism. So in these applications, you can see, if you observe all these, the spot welding, in this case, all these applications, we have used serial mechanisms. Now this also, if you observe, this is my end effector. You can see that there are multiple legs connecting the end effector. So you can see these two comes in the category of parallel mechanism. That means the end effector is connected by multiple legs. Now, let me just ask you one question. Can you tell me what are the possible advantages of a serial mechanism over parallel mechanism? And also, what are the advantages of parallel mechanisms over serial mechanisms? Can anyone give an answer for that? Fine. Okay. So that means in parallel mechanism, if there is a damage in one arm, the mechanism fails. Fine. Okay. Let's not talk about the damage perspective. Let's talk both the mechanisms are in working conditions. Now, so what is the advantage I have? Very good. So it's understood, right? For example, if you see in this case, parallel mechanisms can, so that means if I have some payload on the robot, the load which is acting on the robot is actually distributed by along multiple legs. So in other words, I can actually withstand more payloads on a parallel mechanism compared to a serial mechanism. Fine, that is one advantage. Then the other advantage he mentioned is the level of accuracy. The level of accuracy and precision which has more? Is it serial or parallel? Parallel mechanisms will have more accuracy. Now, what is the reason for that?
Multiple arms locates the position. Multiple arms besides the.
Correct. So that means, in other words, I can say the motions are more constrained in case of parallel mechanisms, or more defined, or it's constrained is the right word. Now, like for example, just imagine this. I'm now using this robotic system for some application. Now I'm using it relatively fast motion, as you can see. And if I'm stopping at one point, what is going to happen? I stop the robot suddenly at this point. What happens? You will see that because of inertia, there will be some shake happening at the. It's an open loop mechanism, right? I don't have any other means to control the unnecessary movements happening at the end effector. Now, on the other hand, if it's a parallel mechanism, what happens? Since it's connected by multiple legs, the movements can be more precise. So that means if I need in applications where more levels of precision and accuracy is required, we normally go for parallel mechanisms. Now, what is the advantage of serial mechanisms?
Maximum reach.
We get more workspace. We call it as workspace. That means a collection of reachable points is what we call as workspace in robotics. So if you see the case of most of the manufacturing industries, we make use of serial mechanisms because we have a larger workspace. Now, if you see in this case itself as an example, so initially my workspace for this arm was this much. You can see it can move throughout this whole space. Now, if I'm constraining, you can see that my motion has got limited because I have one more constraint happening from here. So this constraint has one advantage. One advantage is it makes a motion more precise. But what is the disadvantage? It limits the workspace that I'm going to get for the mechanism. Now, you must have all seen advertisements on medical robotics, or medical surgeries. So what? Now, if you see that in most of the robotic systems, which is used for medical surgeries, the observation that you can see is, we use which one? We'll be using mostly parallel mechanisms because the area of or the workspace that we are looking at is very limited. We are not looking at a large workspace, but what we are looking at is more levels of accuracy and precision. Right? So medical surgery or medical robotic systems are normally comes in the category of parallel mechanisms. And please don't misunderstand that when we say medical surgeries or medical robotic systems, we are not.
The arms are free to move.
Which one?
Serial.
Yeah, the arms are free to move. For what, like what context are you saying?
Operations.
Huh.
Based on target.
Right.
If the arm is free to move,
Hmm.
can cover more area.
No, see, in medical surgeries, normally the surgical area that we are looking at is limited. So we are not, for example, just imagine we are using laparoscopy or some other operations. In laparoscopic treatments, what we have is, normally when a laparoscopic surgery is going to happen, we'll have there will be in total 4 holes which will be made, through which one will give the camera feed, and the other 2 holes will be controlled by the surgeon as such. Now, if we are using a robotic system in place of that, those tools will be actually manipulated by a parallel mechanism. Are you getting what I'm trying to say? So that means we need more precise movements there rather than workspace or reachable workspace. And when we say medical robotics, please do not take the meaning that we are replacing the surgeon. It is actually assisting the surgeon. So the surgeon will be sitting at a distance. We call it as teleoperation. In robotics, we call this procedure as teleoperation, where the camera feed and the doctor or the surgeon, along with a joystick-like device, will be at a distance. The robotic mechanism and the patient will be at a distance. So what is the advantage we get? The advantage we get there is, now if the surgeon is moving that joystick by, just imagine he's moving by 5 centimeters, the mechanism will move by only 5 millimeters. So he can get or achieve more levels of precision and accuracy in doing certain, especially while doing nerve surgeries or such vein operations. And similarly, it also has some other additional intelligence levels where it can limit any unnecessary movements by the doctors and so on. Okay, so those are the other advantages. Yeah.
The complexity of parallel mechanism.
Yeah. So now talking about the construction wise, of course, parallel mechanisms will be more complex. Sorry? The coding in the sense, let's talk it in terms of the kinematics. Because before we code, we need the kinematics ready. The kinematics of a parallel mechanisms is, of course, it's complex. Because if you take the case of a 2D robotic arm, serial, in order to move this arm, I just need to control these two joints. Now, on the other hand, if it's a parallel mechanism, now if you see this mechanism, in order to move the end effector, you can observe I need to manipulate several joints and links together. So which means, of course, the controller complexity and the construction of the robot is more complex for a parallel mechanism. That's correct.
The serial mechanism has more degree of freedom.
Serial mechanisms have more degrees of freedom.
More
Correct. So that's what the dexterity, we call it in mechanisms, in robotic systems, we call this terminology as dexterity. So the dexterity of a serial manipulator is more. Now, what do we mean by dexterity? Now, I just mentioned some terminology called as workspace, reachable workspace. So it's basically a collection of reachable points. Now, there is something else called as dexterous workspace. Now, what does this dexterous workspace mean? Dexterous workspace is actually a subset of the reachable workspace. And this dexterous workspace means if my mechanism is a 3DOF mechanism, within all these points of dexterous workspace, I'll achieve all 3 degrees of freedom. Are you understanding? So reachable workspace means it's not necessary that I can reach there, but it's not necessary that at that point I will be able to get all the possible degrees of freedom. Are you able to understand what I'm trying to say? So that means in the reachable workspace, it reaches, but I may not be able to manipulate at different angles. Dexterous workspace means I can reach that point and I can also achieve all possible orientations in that point. So that collection of points, the collection of those points is called as the dexterous workspace. Now, if you again recollect what Professor Guru Prasad said, he used that, he introduced that terminology called as Jacobian, right? So we make use of this Jacobian actually to decide the dexterous workspace. Because as per the maths, if the determinant of the Jacobian matrix gets to 0, it is we call it as a singular position. If the determinant of the Jacobian matrix gets to 0, that particular point is a singular position. That means I will lose 1 or more degrees of freedom. Are you able to relate what I'm saying? Let's take the same example. My 2D of robotic arm. What is a 2D of robotic arm? One joint here, 1 degree of freedom. Second joint here, 2 degrees of freedom. So this is my 2D of it. Just imagine it to be a planar mechanism. So this is the mechanism. Now I am saying, so mathematically we can show that. Just imagine this is theta 1, this is theta 2. Okay, so both these joints can have different ranges. Now mathematically we can show that this mechanism will get to singular position when theta 2 is 0. So what is theta 2, 0? Meaning this link and this link will be in straight line. So now just imagine this is how my mechanism is. So I can have this two joints to move together, right? Now if I'm assuming this angle, that means if this link and this link gets to be in the same line, what happens? The 2D of mechanism gets limited to a, you can assume this whole thing as one link, because I'm not getting relative motion between these two. Are you able to imagine what I'm saying? So mathematically, for a 2D robotic system, we can prove that when this joint gets to 0, or in other words, when this link and this link are in the same line, we reach singular position. That means in this mechanism, the 2D mechanism gets limited to 1D mechanism. Or as per definitions, one or more of its degrees of freedom is lost. So that position we call it as singular position. So as I told, I'm not going into the maths, especially when we are trying to synthesize a mechanism. When we are trying to develop a new robotic system for certain application, all these concepts comes into play, right? Okay. So this is, I mentioned already about the medical robotics. So this is how it looks. You can see that the joystick-like device will be at one point, the doctor will get the feed, and the robotic system is at a distance. Okay, so this is that joystick-like device. Okay, AR, VR, I believe you know what is this. I need not explain all this, augmented reality and virtual reality, which is, again, there are a lot of scope. Now, what is the difference between AR and VR? What is augmented reality and what is virtual reality? VR, we need a additional device, and it is like we are altogether creating a new environment. It's more like gaming developments and so on. What is augmented reality? So the best example is we have it in our Amazon and Flipkart platforms. In case if you're trying to purchase a new furniture, you can actually position that furniture in your living room, in the real environment. It has that feature. So that is augmented reality. Okay, so I'm not moving into these aspects, right? Okay, I'll just say one more thing. Like as I think he in the introduction he mentioned, I'm also the outreach coordinator for the virtual labs. So we have one platform called as the virtual labs, of which NITK is also one of the 11 institute in developing the virtual labs. Has anyone come across virtual labs? Yeah. So it is like, it's actually a combination of 11 institutes, right? So in case if your institute is not part of any of these 11, so it's like these 11 institutes, of which NITK is only NIT part of this, and then we have the other IITs and all these institutes. So in case if your institute is not part of this, you can again write an email to me saying that you're interested, your institute is interested in being a part of this virtual labs. And the advantage of this is, it's actually funded by the MHRD, the Ministry of Human Resource and Development. And we actually do workshops, hands-on training sessions so we call it as the nodal centers. So NITK is one of the nodal center. And if you have a tie-up with our institute, NITK has a team who will come to your respective institute and give training sessions. It's actual hands-on training sessions. And we do it for different domains, robotics, drone development, AR, VR, gaming developments, and so on. We have n number of platforms. So in case if your institute is interested in that, you can reach out to me and I will be sharing it with the concerned authority who will share you one form. It's just one form which is to be signed from your institute head. So once this agreement is done, then we will, as per your convenience, our team will come to your respective institute and take sessions. So I'm just giving this as an additional info. So, sorry?
How long the training?
So we have 3 to 5 days training programs. We also do 1 day training programs, but 1 day doesn't have hands-on and so on. It will be just theoretical discussions. So depending on what you are looking at, so probably what you're looking at, we can have, you can connect with us, right? So just keep this in mind. So in case if you are interested in being a part of the virtual labs project of NITK, so please write an email to me, and so my contact, you just search for Mervyn Joe Thomas NITK, you will get my details. So you can just write an email, and we can connect after that. Okay. So this one slide I have just added because, like, in the morning again, I realized that certain terminologies which we actually very much use in robotics are not very familiar with the CS and IT people. So I thought, like, I'll just give a glimpse of some of these concepts so that in case when you read some journals related to this field, you'll get some understanding. Now if you come across a journal or an article which is related to the development of a robotic system, these are some of the terminologies which you will see. The first one is, we call it as the POS, POSC, and normally this POS is expressed. Again, I'm not, as I told, this itself is an independent course, so it will take time, but I'll just give you a glimpse. So next time when you come across this terminology or when you come across this metrics, you'll come to know what it is. So that is the reason why I'm discussing this. So POS, in robotics, whenever we discuss anything, or whenever we say something, we normally express it as a 4x4 matrix, and this matrix is called as the POS matrix. Now, what is the significance of POS matrix in robotics? Can anyone give a guess?
Describe the relative position between the joints.
Relative position between the joints. Okay, so okay, so I will keep this, I'll talk here. So now if you observe, in this POS matrix, in robotics, we will be dealing with a space, an environmental space, which is, we call it as a three-dimensional space. So in three-dimensional space, a point is normally defined as, now again, there are different ways where we can define. Again, it's a bit of maths, but like, just bear with me. I'll just make it very simple. So a point can be expressed in different coordinate systems. The most commonly one is the Cartesian space. So Cartesian space is what? The x, y, z coordinate, right? X, y, z coordinates. So x, y. So if I have a point, and if I know the x, y, and z coordinates, I can define this point. So that is a Cartesian space. Similarly, we have similar to that, we have spherical coordinates and cylindrical coordinates also. Okay. Now let's not make it complex. Let's not take into account the other coordinate systems. Let's just limit to the Cartesian space. Now again, in robotics, if you observe, a point is not just enough to define the position coordinates. It is actually incomplete. Can you tell me why?
Orientation is not.
Because the orientation is also equally important. Now just take the example. All of you must have tried to insert a LED bulb to the bulb holder, right? Just imagine that application. So depending on whether it's a pin type or screw type, whatever it is, what is the procedure normally you do? I have the bulb. I know where is the location of the bulb holder. So what do? I will go to that respective position, and I have to orient the bulb in certain angle, insert it and twist it. That is a procedure that we normally do. Now, if I want to do the same thing with a robotic system, I know where is the position coordinates of the bulb holder. So that means x, y, z coordinates are known. But is that enough for me? For me, it is also equally important, as I said, it is also equally important that the bulb is oriented in a certain angle, in a certain fashion, and then we insert it. So which means in robotics, so I'm talking specific to robotics. In robotics, it is not enough to just define the position coordinates and the it is not just enough to define only the position coordinates. We have to also express the orientation alongside. So this combination of expressing the position coordinates and the orientation together is what we call as the pose matrix. So now next time when you come across a journal, if you see this a matrix of this kind, this matrix, this 4x4 matrix is actually expressing or giving me information regarding the position coordinates and the orientation. And again, if you see in robotics, normally if you see a point, normally in a journal or in a mathematical modeling of a robotic system paper, if you observe in the kinematic diagrams, a point is not just defined as one point. You will also observe an axis. You will see the 3 axes, X, Y, and Z axis also defined. So in robotics, it's very important that both the position coordinates and the orientation. Orientation, what I mean is the 3 frames. This has to be clearly mentioned. Now, how do we decode this matrix? What you see in terms of R, the R terms, that is the, we call it this 3x3 matrix is called as the rotation matrix. And the last column, what is expressed in T, is called as the, those are the position coordinates. So T1, T2, T3 are Px, Py, Pz coordinate of the end effector frame. Okay, so I believe you all know how to define Px, Py, Pz. That is already known to you. So if you know the origin, you know the X, Y, and Z directions, you know how to define a point. Now for rotation, to get the rotation matrix, there are certain concepts. We call, for example, the Euler angle concepts and so on, Winkel angle, Cardan angle, and so on. But again, as I told, it is maybe slightly beyond your perspective because since you are not in the hardware development, it is not directly related to you, but it is good that you know what is the concept involved. So deriving this rotation matrix, I'm not, because of the lack of time, I'm not discussing because I believe I'm told probably by 4 o'clock I may have to wind up. So there is some training sessions kept for you after this. So I'm not discussing into how to derive the rotation matrix, but if you have if you are interested, you can refer to any standard robotics introduction to robotics textbooks. You'll get the mathematics involved. Okay, but you should understand. So this matrix, when you see, you should understand that this 3x3 matrix is basically the rotation, and the last column is the position coordinates. And the last row, if you observe the 0, 0, 1, again in robotics, it's normally expressed in zeros and ones. Now, what does that indicate? Those zeros means that we are trying to model the robotic system at normal angles. That means you must have studied probably in your first year engineering graphics, you must have studied orthographic projection. Do you remember orthographic projections? So there are different views, the front view, side view, top view, orthographic projection. Now, if you remember this orthographic projection, we are actually viewing the robot. Okay, yeah. So he saying it's tea break now. I'll just stop with this 2 minutes and then, yeah. So in orthographic projection, what is happening? We are actually modeling a given system, viewing it at orthogonal angles or at 90 degrees. So whenever so again in robotics, for our simplicity, we always model the robotic system at orthogonal angles. So that is why these are in zeros. Now for those people who are studying in computer graphics and so, if they are viewing a robotic system, if you are trying to model a system from isometric directions or perspective angles, these won't be zeros, it will be some other values. And similarly, the last one refers to the scale. So if it is 1, means it is 1:1 scale. If it is some other value, it will be either magnified or scaled down versions. Right? So this is how you should understand. So next time if you see the 4x4 matrix, you should understand that it is like basically expressing the pose of a point in three-dimensional space. So this is how you should understand. Fine. So we'll stop with this for now, and then we'll discuss the remaining aspects after the break.